Welcome to LNP Renewable System Director. Today we are going to discuss about VAV terminal box controllers of Siemens, which has application of 6520. That is cooling only application. If you are going to work in the building management system industry or building automation control system industry, where you can able to go through so many heat ventilation air conditioning systems, say for example air handling units, fan coil units, VAVs. Okay, these VAVs are the field devices. Okay, what are the things that we are going to discuss today? What is a VAV? Where can I see and use these Siemens VAV terminal box controllers? Okay, how it works? Okay, and how it looks like and how it is wired and installed, and what are the things as a building management system engineer or a BACS engineer we should know in this Siemens VAV terminal box controllers. First of all, before getting into the topic, we should know why we are going for this VAV terminal box controllers. Let me tell you in a simple way. See, using DDC controllers, direct digital controllers, also we can control the variable air volume units. Okay, using the PLCs also we can control the variable air volume units. But when you compare the price, PLC will be at the highest, and when compared to PLC, DDC will be little less in price. And when you go for this variable terminal box controllers, these are application specific. So based on our application, we can choose those controllers. Simply we need to plug in and we need to do the basic configurations. Okay, if required, we can also do PPCL programming in these terminal box controllers as well. So we have the codes, we have the objects. Okay, and we have short form codes also to use inside these programs. Okay, these are very simple programs, but by default this will be programmed. Only thing, we need to configure them properly. So what is a VAV? VAV is nothing but a variable air volume unit. Okay, it varies the airflow at a constant temperature. What is the purpose of using these variable air volume units? In order to attain a precise temperature, and in order to reduce the wear and tear caused by the compressors, and in order to reduce the energy consumption, and also in order to reduce the noise pollution created by the fans, and on for passive dehumidification process also we can use these VAVs. Okay, so as I told earlier, using this terminal box controllers, we can control the variable air volume units as well as the fan coil units. So where can I see this? If you are going to work in a metro station in the automation industry, or if you are going for an airport project where you got exposure to work in an automation industry, or if you are going to work in a multi-storage building where building management system is established or building automation control system is established, there where if you find variable air volume units and fan coil, for sure there will be these controllers if Siemens implemented this project. So this is the VAV box. Okay, this is how it looks like in reality. There are so many designs available, but basically this is how it will be. These are the airflow measuring sensors, dampers, and this is the control box. Inside this control box only we are going to fix these controllers. So we have 16 sensing points normally in the sensors. Okay, those sensors will sense the airflow, and this is how it looks like. This is the controller of this VAV controller, the one that we are going to discuss today. See here, basically this is how it looks like. It has a power supply 24 volt AC, and in order to establish the communication with the backnet network, in order to establish a communication with the server through the backnet, we are connecting our Siemens controller here, and we have digital output terminals and we have input terminals. Okay, and using these type of thermostats we used to connect with the RTS ports. And this is a typical basic wiring diagram. So if you have air velocity sensors, those tubes we need to connect here, and we are in order to connect the power wiring, this is the terminals. In order to connect the communication wiring, these will be the terminals. In order to connect the room temperature sensors, this is the port, and these are our DA/DO terminals. And these are the things that you need to know. Okay, in hot we need to connect the phase, and in the cold terminal we need to connect the neutral. And if you are going for a two-wire communication, then in the plus and minus you need to connect your communication cables properly. And LED indication is most importantly, because when you do some sort of programming, or you are downloading something, or when you are doing basic configurations inside that controller, then the first and the foremost thing that you need to know is that it has the digital outputs. Okay, we have LED indication, those digital outputs. Okay, those glowing LED indicates that the particular DO is energized. and if you are trying to transmit some information from the controller to the field device, the transmit LED will be glowing, flashing, and if you are receiving some information from the field panels, then the receiving LED will be flashing. If you are doing any sort of basic sanity test, it will be like a BST LED number 9. It will be on and off per second. It means the controller is working properly. If there is no such sort of indication, then it means there is some issue. Okay, and this is a dimension to if you're going to plan an install inside a electrical panel. These are its dimension in inches. These are the physical connections. So now let's get into the application. Our application is 6520. It means we are going to perform only cooling operation. We are not at all going to connect any sort of heaters in it. Okay, see here, we have a 24 volt power supply terminal, and we are connecting our modulating damper actuators, okay, in the digital outputs. Okay, and also we want to know some sort of sensing. Okay, we are connecting our room temperature sensors here, and if you are planning to do any sort of occupancy, continuously occupancy mode for a VAV, then we can go for auto zero modules, and most importantly the air velocity sensors we need to connect in the tubing connections. And this is the connection terminals. See here, we have a power wiring terminal. This is a floor level network terminals, and in the digital outputs we can connect our damper actuators. And see here, we have room temperature sensor. And most importantly, if you have any plan to provide any analog outputs from 0 to 10 volt, using these controllers we can perform. Okay, and this is the basic wiring. See here, we have a 24 volt AC. So with the help of the step down transformer, we are converting our existing higher voltage to a 24 volt, and this is the communication wiring terminal, and here we will connect our VAV damper actuators. Okay, and in order to get the real temperatures from the field, room temperature, we are using this thermostats. So as we told earlier, if you plan to maintain a constant temperature, and if you plan to operate your VAV in a full time occupied mode, then in such places you can use this auto zero module. Okay, this is a actual site photo of a VAV, how it looks like. And most importantly, if you are going to connect the actuators also require power supply for its operation, and the command signal if you are trying to plan to give from your controller, and this is how the wiring should be. And this is the typical graphics, the simple graphics of how a variable air volume unit you can provide in the graphics format. Okay, most probably this VAV application controllers, the standard controllers will communicate with the backnet routers. From the backnet routers, it will communicate to the servers. From the servers, by mapping, we can see all these values in the SCADA. Okay, see here we have a damper position, and also we are providing the heating commands as well. But in here our application is full and fully damper, so only damper operations positions will be enabled here. And this is how it looks like in the site if installed. And most importantly, when you go for this controllers, it has so many object instances and object names. Okay, so this much things we can do inside these controllers. So we have two different varieties of cooling operations. And if you're going for a control temperature set point operation, we have two modes. One is in the day mode and the other one is in the night mode. Okay, and if you have a set point dial, okay, based on that, it will that value from the set point dial will get cold, and the entire controller will try to maintain that set point temperature. If there is no set point dial, then it will hold the last value, or we can write the set point dial value. Okay, or we can we can write the minimum maximum limit that it can maintain. Okay, and we have a temperature loop as well in order to maintain the temperature loop. Why we are going for this temperature loop means because what should be our flow. Okay, with the help of this temperature loop we can control the flow. Say for example, if your temperature loop out is 0%, then we can set our flow set point to minimum 20%. Okay, if it is a 50, then we can make our flow set point to 60% flow. And if our cooling looping is 100%, then we can also give the flow set point to 100 flow. So this is basically the PPCA programming is being done inside these controllers for the temperature loop operation. And if you're going for a flow loop, minimum flow we need to make, because whenever you're going to commission a VAV, once making every sort of connections, okay, we need to do the air balancing. So from the air balancing, we will try to know what will be the minimum CFL value, okay, liters per second value, or what will be the maximum liters per second value. Based on that, we will try to sort out the minimum voltage required to operate the dampers, we will know, and also the maximum voltage required to operate the dampers, we will know. And if you're going for a flow loop, it will try to maintain the cooling flow minimum value. And if you're going for alarms, okay, we can set a high temperature cutoff alarm, communication failure alarm, backnet router communication failure alarm, and the temperature deviation alarm with a time delay of 60 seconds. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We had provided the contact details here. And also we are providing design, installation, testing and commissioning supports for the building automation, building management system, and we are also providing training and consultancy supports with the certifications. So if you are really interested to work in abroad like GCC countries like Qatar, Oman, Saudi Arabia, if you are really interested, we are ready to help, we are ready to train you with the certification. You can contact us. We have provided the contact details here. If you are really interested to online trainings also, we are readily available. You can contact us. We are providing the contact details here. And also for the solar on-grid, off-grid and hybrid application, we are providing design, installation, testing, commissioning supports also. And for the access control system, okay, through wireless, if you want to connect and if you want to do the home automation for your homes, you can contact us. So we are providing the training as well as installation, commissioning supports as well. You can contact us. We have provided the contact details here. And if you want to know the electric vehicle basics also, you can contact us. We have provided the contact details here. Thank you so much.